Hello, everyone. Welcome to the Math Magician's Den. We are going to talk about a couple of special trig limits at infinity or even negative infinity. Believe it or not, the graph of sine of x over x, we talked about that earlier on. We said that the limit as x approached 0 of sine of x over x, that was equal to 1. And we never even really talked about cosine in this respect. We said the limit as x approaches 0 of 1 minus cosine of x over x. That was equal to 0. Those are two trig limits we did before, but those weren't at infinity. Those were at 0. So how can we figure out what happens here with sine of x over x? How do we know that approaches 0? Well, one of the things we can do, we can talk about the values of sine of x. We know from the unit circle and from graphs of sine of x doesn't go any higher than 1, and it doesn't go any lower than negative 1. Now, what are we doing here? Look at the bottom. We're dividing by x. If I divide by x here, I'd have to divide by x here and divide by x here. At infinity, I'm not dividing by 0, so this is absolutely fine. Now, here's the thing we need to talk about. What's happening here as x approaches infinity? Remember, x is approaching infinity. Well, negative 1 over infinity would be 0. 1 over infinity would be 0. So what do you think sine of x over x is going to approach? Well, by the squeeze theorem. Sometimes this is called the sandwich theorem. By the squeeze theorem, if a function lies between two other functions that approach the same thing, this middle function, well, guess what? It also has to approach 0. Now, we can use this exact same proof for cosine, because cosine also lies between negative 1 and 1. I could again divide everything by x. And like we said, as x approaches infinity or negative infinity, this would go to 0, this would go to 0. And since cosine of x over x is between them, it would also have to approach 0 by the squeeze theorem. So these are two special functions that we talk about with trig and end behavior. Now, when you take a look at the graph, I'm going to show you the graph of sine of x over x. I hope you notice in the middle it goes up to 1, but as I move further and further to the right, that wave gets less and less. And if I zoom out, you can tell as I go to infinity or negative infinity, it's starting to get smaller and smaller and smaller. Those waves are actually approaching 0. And what I'm going to do is I'm going to get back to that window I was in before. And let's turn off sine of x over x and let's look at cosine of x over x. Now, cosine of x over x at 0 is undefined, but look at the waves again. As you move further and further out from the origin, those waves get less and less. They're going up and down, less and less. They are approaching 0. So you can see that on the graph as well. We'll get back to that window we were just on before. Now, what happens, okay, I'm going to turn off cosine of x over x. What happens if I put a 2 here? Well, it made the waves higher and lower. So I changed the amplitude a little bit, changed how tight they were, but you'll notice those waves are still going up and down less and less and less as I move left to right. So sine of 2x over x would still approach 0 at infinity. Well, what if I put a number on the bottom? It's still got waves as you go to infinity and negative infinity that are approaching 0. It's the same thing if I try cosine of x over x. Let's say up here, I actually put a 10. Now you notice I have more waves, but look at those waves. As I go left and right, they get less and less and less. They still approach 0. If I put a 4 underneath here, the waves aren't as tall, but guess what? As you move to infinity and you have approached negative infinity, those waves get less and less and less in terms of their amplitude. So it doesn't matter what numbers I put here. I could put sine of 2x over x. I could put sine of 2x over 3x. I could put any number in here, and it's still going to go to 0. Okay? So keep that in mind when you're doing some of these trig functions and you're talking about limits at infinity. Now let's talk about the problem below there. How would you work this problem out? Well, I have got sine of x, and I know the limit that I have to deal with is sine of x over x. So this is one way a student told me to do this. They said, hey, split it into two fractions, x over x minus sine of x over x. That's a great idea because this first fraction, x over x, approaches 1. And sine of x over x, the limit of that is 0. So this limit goes to 1. Here's another way to think about it. Take everything in this limit and let's just divide by x. So x divided by x minus sine of x divided by x, and on the bottom, take x divided by x. This would reduce to 1 minus the limit of sine of x over x would be 0 all over 1. And I still end up with the same answer. Now, I wanted to show you the idea of dividing by x because that does a lot for getting rid of some of the polynomial parts of these problems. So take a look at the problem that's next over to the right and up. This one right here. What are we going to do to try and figure out this limit? Well, we know that what I want is for sine and cosine to be divided by x. So let's divide every single term by x. So that sine of 8x over x allows me to figure out what that limit is. And all the polynomial terms, if I divide those by x, that's a rule or a procedure that I can use and that I've used in the past on other rational expressions. Now, what would this come out to be? Well, 7 over infinity, that goes to 0. This term reduces to negative 4. Sine of x over x goes to 0. We just discussed if you put any number in there, it's still going to go to 0. So this would be plus 0. The top is negative 4. The bottom, this term reduces to 7. And cosine of 8x over x, this term also is going to go to 0 by our formula. So my answer is negative 7/4. And you would have the same answer if you went to negative infinity. Now, I've thrown this last problem in as kind of a challenge problem. What are we supposed to do if you see a problem like this? Well, my first inclination is to say, I'm going to divide everything by x like I did in the previous two questions. So I'm going to put x over x on the top. I'm going to put 3 over x here minus cosine over x here. Now this reduces to 1 over 0 minus 0, so this is actually 1 over 0. Now, we discussed this in another video. If you've been watching my videos, that 0 on the bottom, we have to decide, are those positive numbers approaching 0? Or are those negative numbers approaching 0? Because if these are positive numbers approaching 0, this goes to infinity. If these are negative numbers approaching 0, the answer is going to be negative infinity. And guess what? I got to figure out which one it is. So here's the thing. What I need to know is, what's bigger, 3 over x or cosine of x over x? I can tell you right now, just by looking at this, cosine of x is smaller than 3. Cosine of x can't go any higher than 1. It can't go any lower than negative 1. 3 minus negative 1 is positive. 3 minus 1 is still positive. So on the bottom here, this is positive numbers that are approaching 0. And 1 over 0 is always infinity or negative infinity. In this case, there are no negatives. This graph would go to infinity. I hope this helps with some of your trig functions and their end behavior. You may run into this on some of your limit questions. If you like this video, please hit the like button. And if you love my videos and they've been helping you, subscribe to my channel. I'll be posting more videos as time goes by.